So we're going to have a string of shorter videos explaining about capacitors. So a capacitor is a device or component or load that you find in electrical circuits, and this is its little circuit diagram here, its symbol that you find. And capacitors are pretty much like it looks on the diagram. They're made up of two conducting plates, so two kinds of metal plates of some sort, separated by something that's an insulator. Now we call that the dielectric, which is between them, and it can be anything insulating. It can be air, although that's not very satisfactory. It can be plastic, it can be waxed paper, anything that separates them out. And the capacitance of a capacitor depends on its physical structure, and it's given by this formula, that the capacitance equals the permittivity of free space, which is a constant that you'll be given, the permittivity of whatever the dielectric is, the area of the two plates, and the distance that separates the two plates. So you can build capacitors to pretty much have whatever size that you want. The thing you find in practice, however, is that capacitance is usually a very small number. So capacitance is measured in farads. You usually find microfarads, maybe millifarads, sometimes even down to picofarads. They are a very tiny, tiny, tiny thing. So capacitors behave in a certain way in a circuit, and I'm going to just connect it up to a circuit and we'll talk about how it behaves. So I hope you can agree that when I connect up the circuit, the first thing that it tries to do is start a current flowing because of the potential difference provided by the power supply. So at first, it's going to be really easy for the electrons to jump off the terminals of the power supply and work their way around the circuit. So over time, this plate here is going to fill up with charges because the electrons are running around the circuit and building up over here. At the same time, electrons are jumping off this plate and running around here. So we get a charge difference, a potential difference. So at the beginning, there is no potential difference between these two plates. The voltage across the capacitor is 0 when we first connect it. Over time, it gets bigger and bigger and bigger. It builds up. And we're going to go on to that in the next video. We're going to talk about specifically why and how it builds up.